College special lecture on the environment. It's called the Daffodil Lecture. For us, daffodils symbolize the environment because they are perennial. Every year is a new beginning. And we will have many new beginnings, and certainly in fall of 2013 when our new complex is opened. We're looking forward to that. Yes, you can clap. Now, tonight's lecture and refreshments are sponsored by Phi Kappa Phi Honor Society. One of the student vice presidents is here to introduce our speaker. Ethan Dezell is a political science major in the class of 2012, and he will now introduce our esteemed speaker. Ethan?
Good evening. Tonight, I have the distinct privilege of introducing a distinguished professor at the UMass Department of Geosciences, the research director for the Climate System Research Center, Dr. Raymond S. Bradley. Dr. Bradley is accomplished, to say the least. He received his PhD in 1974 from University of Colorado Boulder. He has written or edited 12 books and over 120 papers on climate change. He has received grants from the National Science Foundation, the National Oceanic and Atmospheric Administration, and the Department of Energy. Dr. Bradley is particularly interested in the variation that has occurred between the climate of present day and that of the past, as well as what may have caused such variation. By elucidating this difference between past and present climates, Dr. Bradley's research, along with others in the field of paleoclimatology, has helped us to come closer to understanding the relative level of responsibility that humans have had in regard to global warming. In his latest book, Global Warming and Political Intimidation, Dr. Bradley discusses the unfortunate consequences of governmental attempts to suppress empirical evidence on climate change, as well as his personal experience and hardships because of such oppressions. Despite such hardships and throughout his impressive career, Dr. Bradley has set the example of the type of scientist and researcher that will be needed as the issue of climate change is shown to be ever more dire than suspected, and requiring the immediate attention and concern of humanity. His commentary and opinion on possible courses of action to address the issue should be given the utmost consideration. On this note, it is my honor to introduce today's speaker for the Daffodil Lecture Series, Dr. Ray Bradley.
Good evening. Let's turn my mic on here. Good evening. It's a great pleasure to be speaking to you tonight. I have the greatest admiration for Commonwealth College and even greater admiration for your dean, Priscilla Clarkson. And I can say without hesitation that every time I've had Commonwealth Honors students in my classes, they've been superior, top-notch guys. That's you guys I'm talking about. So I'm very happy to speak to you this evening. I'm going to talk to you about the planet under pressure, status and future prospects. What I'm really going to try to talk about is the problems of sustainability, and not sustainability on a local scale, but sustainable development on a planetary scale. How do we achieve a more equitable society, sharing resources, managing our environment on a global scale? And last week I was in London at a conference with this, more or less this theme, big international conference. And the first lecture was given by a very distinguished scientist, the British Astronomer Royal, Lord Rees. And he began with something that's stuck in my mind ever since. He said, he's an astronomer. He's not a geoscientist or a political scientist or a social scientist. He said, When I think of the Earth, I imagine somebody looking at the Earth, another civilization, way out in space, looking at the Earth. And they've been tracking what's happening on the Earth over long periods of time. For 45 million centuries. That's how old the Earth is, 4.5 billion years, 45 million centuries. And over that period of time, this observer in space has seen changes take place. The continents moving, rise and fall of mountain ranges, ice ages coming and going. But these changes have been very slow and very deliberate, you might say, very slowly evolving over time. And these observers have suddenly noticed in just the last 1 or 2 of those 45 million centuries, dramatic changes that are occurring at a rate much faster than any of the previous centuries, or almost all of the previous centuries that these observers have been looking at the Earth. And that's what I want to talk to you about this evening, the rates of change in our natural environment, changes in the atmosphere, changes in the oceans, changes in the terrestrial realm, all driven by our increasingly global society. So let me start off with a little video here that kind of brings this together in a visual way, looking at the evolving Earth over the last couple of hundred years. And what you're going to see is a picture of the Earth, but you'll also see a graph that describes a number of parameters. It doesn't really matter what it is that you're looking at on the graph, what parameter that is, whether it's greenhouse gases, carbon dioxide, whether it's the loss of biodiversity, whether it's acidification or eutrophication of lakes and streams, whether it's erosion on the landscape. All of these changes are taking place more or less simultaneously as our global population increases. And the rate of change is accelerating through time, as you'll see. So let's see if this works. Oops. So, what caused these changes? The Industrial Revolution began in the 18th century in the north of England with the invention of the steam piston engine. And the driving force for that was coal. This led to a huge shift in population from farms to factories. And as that happened, it led to the rapid growth of urban centers. And as those urban centers expanded, it led to the demand for more improved transportation systems, the development of road and rail systems, linking those urban centers. In the late 19th century, much of that manufacturing shifted to Asia, to India, to China, to Southeast Asia, leading to huge urban centers developing in those regions too. After 1950, and you can see on the graph the acceleration here, growth in all areas exploded. Standard of living in Western democracies improved dramatically, especially in North America. Our economy exploded, but the cost was quite severe, especially in other parts of the world, with the demand for food and natural resources, destruction of tropical rainforests, and the loss of biodiversity. Much of that involved what some people call robber economics, where we were exploiting the resources of other countries, leaving their populations behind in the race for a higher standard of living, leaving people malnourished, without education, without health benefits, and so on. In recent decades, these trends have continued. Trade, explosion in international tourism. Few people in this room, I'm sure, have not been on an airplane. The human impact on land, ocean, atmosphere has increased. So we're now a more connected world, electronically, by TV, by satellite. We can't exactly see through the Earth anymore, but we are connected. We know what's happening all over the world almost instantly. And now we must decide how we're going to manage the Earth to create a sustainable future. We're using up resources at a phenomenal rate. Our population is growing relentlessly, and we cannot continue on the path that we are on. It's simply unsustainable. So with that introduction, I want to now examine just a few of those issues that I've touched upon and try to document and explain what the issues are in terms of environmental change and what we need to do about it. Let's start off with greenhouse gases. That's the one I'm perhaps most familiar with. It doesn't matter where you are on the planet, whether you're at the South Pole, at the North Pole, or in the middle of the Pacific, you can measure the impact of industrialization because we're burning fossil fuel, mostly in the Northern Hemisphere, but the atmosphere is well mixed and it very quickly spreads throughout the world. So even at the South Pole, where clearly there isn't much in the way of industrialization, we can measure the impact that we're having. And we can see, here's a graph from 2000 to 2007. In all of these places, the CO2 levels are rising. Now, if we just look at the record from the northernmost point, here at Alert in Canada, we can also see that superimposed on this rise in this case carbon dioxide, we see this annual cycle. And this reminds us that what we're seeing here is the breathing of the biosphere. During the spring, when all the leaves come out on the trees, as they're going to do soon, carbon dioxide is extracted from the atmosphere and fixed through photosynthesis into the tissues of plants. And that, on a global scale, actually draws down the levels of CO2. And that continues until the fall, when the leaves fall and the biosphere essentially comes to a halt in the Northern Hemisphere, the activities, and the CO2 levels go back up. So this is the annual cycle of CO2. This cycle reminds us what happens when we burn fossil fuel. Fossil fuel is essentially that plant material that was extracting carbon dioxide from the atmosphere hundreds of millions of years ago. It was taking that CO2 out of the atmosphere, fixing it into plant material. Those plants were eaten by animals, and eventually, through geological time, that material got compressed into coal and into oil. And we're now extracting that material and putting it back into the atmosphere at a phenomenal rate. And as Lord Rees pointed out, to the observer in outer space who's sensing what's happening to our atmosphere, he's seeing a very, very rapid change in the levels of greenhouse gases, whereas the extraction of that carbon dioxide hundreds of millions of years ago took tens of millions of years. And so we've accelerated the rate of returning the CO2 to the atmosphere very, very much. Why do we care about these gases? They are greenhouse gases. They allow radiation from the sun to pass through. They're transparent to shortwave radiation, but they trap radiation that's emitted from the surface of the Earth. This is what we refer to as the greenhouse effect. Some people call it a global quilt. It essentially, like having an extra duvet on your bed, it traps that energy that would otherwise escape this space. And so slowly, bit by bit, the atmosphere is warming up, and not just the atmosphere, but also the oceans. I'll come back to that later. Let's just look at the rate of change. Here's the last 7,000 years. Here's the record of carbon dioxide in the atmosphere. Varies very little, somewhere around 270, 280 parts per million by volume. And then it starts to rise very rapidly. And that rise is driven to a large extent by the growth of world population and the demand for a higher standard of living. And I'll talk about that in a minute. Now let's focus a little bit just on the last 1,000 years or so of this record. Look at it in a bit more detail. Here we can see the CO2 record in black. That's the greenhouse gas I've been talking about, but there are many greenhouse gases that we're producing. Nitrous oxide, which results from the application of fertilizer to our agricultural systems. Methane, much of which comes from irrigated land, rice paddies and so on, and also from grazing animals, cows and sheep and so on. And we see from 1,000 years ago, more or less a flat line here of CO2 at around 280 parts per million, methane at around 700 parts per billion, and then a sudden rise that takes place somewhere around the end of the 19th century. What caused that rise? Well, it was the beginning of the Industrial Revolution. James Watt and Scott invented the steam piston engine in 1784. And I'm sure he never had any idea what he was doing to the global atmosphere, but this machine demanded coal. It was fed by coal, it was powered by coal. And that led to the growth of the coal industry. It led to factories being built. It led to the migration of people from the countryside to the factories. It led to the growth of an urban civilization, whereas previously it had been largely an agricultural civilization. And then these steam engines were applied to transportation. We had the steam trains. Those of you who have been from Springfield to New York will know that we still have one of those, I think, running on Amtrak. And then following that, about 100 years later, Mr. Daimler and Mr. Benz patented the internal combustion engine, which took the demand away from coal to petroleum products. And suddenly the demand shifted away from coal to oil. So you can see the inflection point in the CO2 here is right about those two intervals of time. And the result of that is that CO2 levels are now at 390 parts per million by volume in the atmosphere. 390 parts per million has not been seen on Earth for literally the last several million years. Million years. And that's all happened in the last 200 years. Now, what are the results of that? I'm going to talk later on a little bit about nitrous oxide here, but let's just look at the consequences of that for our global climate. Here we see the record of global temperature. This just goes back to 1880. We see this relentless rise in temperature, the global warming that we all talk about. It's not a perfect increase. There are uncertainties indicated in green here. But it's quite clear that this record of global temperature, based on these literally thousands and thousands of stations around the world, document the increasing effects of greenhouse gases in the atmosphere. We cannot explain physically the rise in temperature without considering the role of greenhouse gases. And no matter how many times people say this is not real, the facts speak for themselves. This is just the average temperature of the globe. But what we also see is that there's an increasing number of extremes taking place. Those extremes might be tornadoes, hurricanes, extreme events, flooding, rainfall, drought, and so on. And this graph here shows the number of natural catastrophes over the last 30 years. Now, this is not a graph put together by some wacko environmental organization that might want to, slant the data to prove its point. This is put together by Munich Re, one of the biggest reinsurance companies in the world. This is a company that tracks disasters because that's their business. That affects their bottom line. And this is one of the few companies, types of company in the world that are screaming out for legislation to control greenhouse gases because they can see the impact. 90% of the events in 2011 were weather-related. There was a big earthquake, of course, and tsunami in Japan, which you can see here. These are the red events, geophysical events, earthquakes, volcanic eruptions. But all the other events on these graphs here are meteorological, hydrological, or climatological events. 90% of those events in 2011 were weather-related. Overall, insured losses were the second highest on record since 1980. The insured losses were $201 billion. And a lot of people would say, well, that's just because we're building more and we have more expensive houses and so on. Not so. The head of Munich Re's risk division, GeoRisk, says the increase in losses is driven not by population growth or by value growth, but by more extreme events and more intense events, which is what models of the future impact of CO2 have been telling us for a long time. And this just shows the distribution of those catastrophes in 2011. And I'll just point out the climatological events, heat waves, cold waves, wildfires, drought, and hydrological events. Look at the concentration of those events, which are in red, which are in yellow and green in Western Europe and North America. We've had a succession of dramatic extreme events over the last year or so. Now, I talked about the acceleration, the rate of change. And if we look at any number of measures, let's just start off here with carbon dioxide. And these graphs all begin in 1750. I know this is hard to see. 1750 to 2000. Here's the rise in carbon dioxide, the rise in nitrous oxide, the rise in methane. After about 1950, after the Second World War, things really took off at a much faster rate. This has been called the Great Acceleration. You can see this in many, many measures. Here, ozone depletion really began in 1950 with the development of industrial gases, chlorofluorocarbons, which didn't exist before that time. These are purely industrial, man-made gases that started to deplete the ozone in the upper atmosphere and increase the level of ultraviolet radiation being received at the surface of the Earth. Here's another measure, shrimp farming. Who gives a damn about shrimp farming? Well, it turns out that shrimp farming destroys mangroves and coastal resources in many parts of the tropics. Look at the growth in shrimp farming. Global biodiversity, this is species loss. Extinction is forever. We're losing tremendous resources as tropical forests are removed, largely for what? To grow soybeans and other products to feed cattle. Here's a few more measures, and let's start at the top right here, population growth. I'm going to come back to this in a minute, but certainly there's been a sudden rise in population since the 1950s. I think I'm correct in saying that since I was a graduate student, and I know I'm an old fart, but I'm not that old. Since I was a graduate student, the world population has doubled. It's now 7 billion, and it'll be 9 or 10 billion by the time you graduate. No, perhaps not that soon, but in your lifetime for sure. Look at some of these other things. This is the growth in GDP. Come back to that in a minute. Is that a useful measure? Should we be looking at economic activity in that way. Fertilizer consumption to drive the demand for food. Number of McDonald's restaurants. That's a proxy, if you like, for the demand for meat. International tourism. It was almost nothing in 1950. Now everybody travels the world at the drop of a hat. Number of motor vehicles. 1950, there were something like 30 million cars on the road. Now there's 700 million. 700 million. And so on. The population of urban centers has doubled, tripled, quadrupled. 50%, more than 50% of the people in the world today live in urban centers. Now let's take a look at one or two of those measures. I've talked about the rise in carbon dioxide, but that has a very important effect, not just on the atmosphere, but also on the oceans, because almost half of the CO2 that we produce by the burning of fossil fuels is absorbed in the oceans. Thank God it is, because otherwise we'd be in really deep trouble. The CO2 levels in the atmosphere would be so much higher. However, the consequences of that are an increase in acidification of the ocean. That CO2 dissolves in water to form carbonic acid. That hydrogen ion soaks up the carbonate ions in the water, and that takes it away, if you like, from organisms that produce calcium carbonate, organisms such as coral reefs and other calcareous organisms. Unfortunately, we don't have very long records of ocean acidification, but you can see here beautifully, here's the record of carbon dioxide in the atmosphere measured at Mauna Loa, Hawaii, since 1957. Here's the pH measured off the coast of Hawaii over the last 20 years or so. So as the CO2 levels have risen, the pH has been becoming more acidic. Now, if we look at the distribution of conditions that are conducive to calcareous organisms around the world, I won't go into the details here, but let me just say that if you look at the boundary between the purple and the yellow here, that is the sort of limit that allows calcareous organisms to survive. And this is the condition under 280 parts per million. That was the pre-industrial level, the way it had been for thousands of years, more or less steady at 280. We're now at 390. And we're heading rapidly to a level like this, 450. I'm sure we'll be at 450 before very long. Now look at the boundary between the orange and the purple. You can see it's this area that sustains coral reefs has shrunk dramatically. In particular, look at the situation here off the coast of Australia where the Great Barrier Reef is. So we're changing the chemistry of the ocean by the rate of fossil fuel consumption. And this is what coral reef scientists have projected will happen. Here we have a healthy coral reef, more or less healthy today. Temperatures have gone up, CO2 levels have gone up, but it's still surviving. But if we go to 450 parts per million and we put additional stress on the communities because water temperatures are rising, then it's going to become much more difficult for these organisms to survive, and eventually we'll end up with something like this. Now let's turn to the terrestrial biosphere. Of course, we've been, as our population has grown, we've changed the biosphere of the Earth, we've changed the surface of the Earth. This is an interesting map that shows how long we've been using the landscape, how long we've been using natural resources. And the purple colors are just for the last couple hundred years. The browns here represent the older civilizations, where in China, agriculture has been going on in the Huanghe, for example, for the last 6,000 or 7,000 or 8,000 years. So these landscapes have been transformed for a long period of time. But in North America and South America and much of the southern hemisphere, these changes have been more recent. But they've nevertheless been quite relentless in changing the sorts of land use from a natural, very often a forest system, to an agricultural system. And that's had its effects also on animal populations. 10,000 years ago, just at the beginning of the agricultural era, 0.1% of the mammal biomass, that is humans and animals, or 0.1% was made up of humans and domesticated animals. Now it's 90%. 90% of the biomass is basically a system to provide meat to eat for the developed, largely for the developed world. So the biosphere is under pressure. There's increasing pressure on biodiversity, and there are various measures that are looked at here: population trends, habitat extent, community structure. And you can see over the last 30 years, these various measures have declined. The pressures have increased. Number of alien species, invasive species, exploitation of these landscapes. And yet we have responded. We have managed to persuade people to protect natural areas. The number of protected areas has increased, actually. We've done quite a good job of that. But it still hasn't yet got much traction in terms of stopping the decline in biodiversity in many parts of the world. So we have to do a better job with that. Let's just quickly look at the hydrological system. How much water do we use? In many parts of the world, which are really arid and very difficult to sustain crops, we've invented these ginormous irrigation systems, centrally linked to a well, and then these things swing around in a great circle, like you've seen, I'm sure. That water is being drawn from resources that are, in many parts of the world, not being restored. If you fly over any part of the Midwest, Nebraska, Kansas, South Dakota, all the way down to Texas and Oklahoma, you'll see this pattern where these big circles show up when you look down. And those are these irrigation systems that are spinning around, drawing water out of groundwater that probably accumulated in many parts of the region literally tens of thousands of years ago. These are resources that are not being replenished. If we look in the area from Texas up to Nebraska, we have this huge aquifer at depth called the Ogallala Aquifer. And here, the same geographical domain, we can see how much this resource is being depleted. The red here shows that the level of water in that aquifer has fallen by more than 150 feet. So we're using a finite resource. It won't last forever. And if we look at what's happening in other parts of the world, I was looking at a map of parts of the Sahel in Africa, we see the same irrigation systems being developed. And they're drawing on groundwater resources that were put there in the last 10,000 years. They're not being replenished. It's a desert area today. At the same time, we're also increasing the amount of erosion from the landscape. This green line here shows the average estimated soil or sediment loss from the world land surface to the ocean, 7.5 billion tons a year. This is a log scale here. Look at what's happening. Human-induced erosion now has increased to more than 100 billion tons a year. And we're all familiar with this. We see soil washing away. We see deflation, wind blowing soil into the atmosphere, and so on. That's happening over and over in many parts of the world. We're also having a big impact on the river systems. This is the Yangtze River Dam in China, one of the largest dams ever constructed, that dams up the river all the way back to the Three Gorges in this direction. The number of dams we've built is quite astonishing. Let me just show you a little video that illustrates this. This starts in 1800. You see the date on the top here. And each of these represents a dam being built each year. Check out what happens, especially in the last 50 years. So what we've done is we've interrupted the natural flow of water to the oceans many, many times, and those dams are backing up the sediment, the movement of material that would otherwise reach the oceans. Now let me turn to pollution and just give this as one example. This is so-called reactive nitrogen. Under natural circumstances, just bear with me for a minute, how does nitrogen in the atmosphere as a gas get into the biosphere? There are plants and microorganisms. This BNF refers to biological nitrogen fixation, fixing nitrogen into a biological resource. And you can see in 1860, 1990, and projected 2050, these numbers don't change very much. This is the natural system. Now let's look at the anthropogenic system. In 1860, this industrial process, Haber-Bosch, didn't exist. It was invented in 1913, and it took nitrogen out of the air and combined it with hydrogen to produce ammonia, and that was used for fertilizer. And you can see that in the 1990s, 86% of this was used for fertilizer. And so we can see what's happened by nitrogen fixation, by industrial processes, production of nitrous oxide from burning of fossil fuels, and the change of our agricultural system to fix more nitrogen into the soils. So now in 1860, the human activity was about equivalent to the natural system, but doubling the amount of nitrogen. Now look at the situation here. The population here went up by a factor of 4, but the amount of nitrogen being produced on the landscape went up by a factor of 10. That nitrogen enters the rivers and streams and eventually reaches the ocean, where it causes eutrophication, it causes oxygen depletion in the coastal landscape. We hear about these dead oxygen zones south of the Mississippi River and other parts of the world. That's largely related to the movement of nitrogen out of our agricultural landscapes. And you can see here in the 1990s how different it is from the 1860s. So all of this nitrogen that we're putting on the land to improve our agricultural production, to make more food, to feed the growing population, is having very deleterious effects on the environment. All right, now let me turn from environmental problems to what we might call socioeconomic problems. Population growth and the growth of consumerism in the middle class, consumption. Let's just look at the population trends. Arguably, in all of human history, it wasn't until 1800 or thereabouts that the first billion people could be counted on the planet. The second billion took about another 130 years to be produced, so to speak. So by 1930, the population was 2 billion. By 1960, 3 billion. By 1974, 4 billion. Now we're adding 1 billion people every 12 to 14 years. 1 billion people. Over the next 12 to 15 years, there will be 500 more Africans, 500 million more Africans. There'll be 500 million more Asians, because most of the growth is taking place in those areas of the world. It's a phenomenal rate of change. It's something like, adding the population of Massachusetts to the world every month. And of course, we have to feed and clothe and protect and sustain the health of those populations. Now, most of those people, well, I shouldn't say most, about half of those people are still living, those poor people in the developing world largely, are still living an agricultural lifestyle, and a very, very hard lifestyle too. And the production, the yield from agriculture in those regions can certainly be improved dramatically. But in many parts of the world, what you eat is what you grow. And with the changes in climate and the pressures from development on these rural regions, this is an increasing problem for many, many people in the poorer parts of the world. Now, I said that population is going up by 1 billion in 12 years, another billion people. Half of the people on the planet now live in cities. This is Dhaka in Bangladesh. And people in cities demand resources that have to be transported from other parts of the world for food, for transportation, for energy consumption in general. Check this out. You know what this is? This is a job fair in China, in Shenzhen province. Urban populations require jobs. People need to earn money to sustain their standard of living. And that generally requires manufacturing. It demands more consumer goods. It requires people to consume more in order to employ people, pay for advertising, pay for transportation, pay for packaging, and so on. It's a vicious cycle. These people are all looking for a job. I hope you'll be not quite in that position when you graduate. Now let's look at the population. This graph shows global population here in billions. And here is global GDP, gross domestic product. Most of the growth in the economy has come in these OECD countries. That is basically the West, the Western democracies, the developed world. Most of the population growth has come in the non-Westernized countries. And yet the growth in the economy, the standard of living, if you like, has not been equal by any means. Clearly, the West, if you want to call it that, has taken the vast share of resources. The standard of living of the West has increased. Basically, that means more and more consumption. Of course, this group of communities, this group of nations, wants to be like this. And that's going to be a very hard thing to manage. This is a very disturbing picture, but this is really what I'm talking about. On the one hand, we have communities of the world that have no resources, that are living literally hand to mouth, that are going to bed hungry, that don't have any opportunities in education, in health, in employment. And then we have, represented here, the problems of the West: overconsumption, obesity, overuse of resources. Clearly, these two problems have to be reconciled. We cannot continue on this path at the expense of people like this. So, how can we solve these problems? How can we build a more sustainable and equitable global society? And I recognize that what I've been describing to you is a pretty depressing picture. And unfortunately, it is a depressing picture. But we have to grapple with it. And as I've been thinking about this, it's become obvious that, I work in this part of the system, biophysical systems. I can document what's gone wrong in the environment. I can see the changes that have taken place, and I can see why they've taken place. And there are people looking at human systems, and they're looking at how societies have evolved and what problems societies have faced and dealt with. But what's really missing in the middle is this big oval, which is governance. How do we manage? And that it comes down to, we can't solve these problems just by dealing with the environment. We have to bring political scientists and social scientists together. We have to grapple with these larger issues of how we can create management systems that will allow us to have a more equitable world. And one of the questions that arises from that is, we measure everything in terms of GDP, in terms of consumerism, consumption. And that clearly, that cannot continue. We cannot continue to do that. We need to develop a new measure of human well-being. I was interested to read in the paper the other day that the Bhutanese government, Bhutan, is going to have a debate in the United Nations this week, I think. They have developed what they call their index of gross domestic happiness. And the question is, how can we have a society that is more, that expresses itself not in terms of consumerism or consumption, but in terms of overall well-being? One of the talks I heard last week in London was by a social epidemiologist who was looking at the inequities between the rich and the poor, not simply between rich countries and poor countries, but within countries, like the United States. And he was comparing Western democracies. And he looked at all of the countries that had the biggest discrepancy between the rich and the poor, where everybody was trying to be richer, everybody wanted to have more consumer goods. And he looked at various measures of social well-being. And guess what? The more there were inequities between the rich and the poor, the more societies suffered in many, many ways. Societies were not happier by seeking ever more riches from consumption. And I think that's something we've got to come to grips with individually and as a society. So I think solving these environmental problems and addressing these socioeconomic challenges requires reforms of governance structures locally, regionally, nationally, and internationally. For example, we have a Security Council in the United Nations. We need a Sustainable Development Council. We need something that brings together the big players, the G8, the G20 countries, to ask themselves, how can we build a more sustainable world? Not simply be concerned about security, international security. That, of course, comes into it. But we have to have new measures of sustainable development, and we have to seek ways of dealing with that. 20 years ago, there was a big conference in Rio. George Bush, the first George Bush, was president at the time, and he went to Rio and he signed this declaration on environment and development. And believe it or not, these were some of the points highlighted in that declaration. It said, our goal is to achieve sustainable development. Environmental protection shall be an integral part of development. It said all states shall cooperate in eradicating poverty. It said the needs of developing countries, particularly the least developed, shall be given special priority. It said states shall cooperate in a spirit of global partnership to conserve, protect, and restore the health and integrity of the Earth's ecosystems. And it says we should achieve sustainable development and a higher quality of life for all people. And we should reduce and eliminate unsustainable patterns of production and consumption. And every leader, every world leader in Rio at that time signed that document with great fanfare. And clearly we've failed miserably at enforcing that. So you have to ask yourself, what is it that we can do to create an international structure that would allow us to fulfill these goals? It's not just words on a page. We've got to actually get on with the task. We've got to have enforcement. We've got to have some structure. I'm not talking about world government, by the way, in case Rush Limbaugh is listening. I'm talking about new international structures of cooperation in order to achieve these goals. Well, that was 20 years ago. This year, in June, there'll be another international conference, and you'll read a lot about it in the press. It's called Rio Plus 20, 20 years later. Making it happen. Well, I hope this time they make it happen. It's the United Nations Conference on Sustainable Development. We don't know yet whether President Obama will go. They're hoping that every world leader will attend. And as Ban Ki-moon said, small actions taken by each of us multiplied across communities can create a better world. This should be one of the major efforts that we all individually and collectively aim towards. And I'll end with this quote, which actually I didn't realize comes from Martin Luther King. And it was in his famous I Have a Dream speech. And he said, "We've come to this hallowed spot to remind America of the fierce urgency of now. This is no time to engage in the luxury of cooling off or to take the tranquilizing drug of gradualism. This applies exactly to the environmental and social problems that we have today. The fierce urgency of now. We cannot afford to wait. The environmental problems are too severe. The pressure on poor people of the world is too severe. We have to act. And we can certainly expect our national leaders to act when they go to Rio, but I would end by just saying we as individuals must also act. You've all heard that phrase, think globally, act locally. We must do that. We must grasp the nettle. We must, and in particular, we must participate in the political system. We must vote. We must demand of our political leaders the reforms and the changes that we all know have to take place. We cannot continue on the path we're currently on. And we should go to debates, and I'm not just talking about presidential debates. School boards are demanding that kids not be taught about global warming. Go figure. We've got to participate in the political process at every level, locally, regionally, at the state level, and at the national level. And I hope you'll all do that and bear some of these issues that I've mentioned in mind. And I'll finish with this final figure, which shows the world at night. And of course, it's an artificial figure. Not everywhere is dark all at the same time. But I think it does show distribution of the world's population, and bear in mind that that's going to increase dramatically. And I think, metaphorically, much of the world is indeed asleep on these issues, and that we have to wake up and do what we can to shake the leaders that we have to take action and participate in that action ourselves as well. Thank you very much.
Professor Bradley, I want to thank you for that eye-opening, interesting, and provocative talk. Thank you for sharing your time with us and your expertise. We have a small token, let's see, poster that we hope you'll hang proudly in your office. Anyone who has questions can come down and sit in the front to ask questions if you have to leave because you're studying for an exam. Please go ahead and do so now quietly and quickly. Anyone wanting to stay and chat, please come down in the front row.